Okay, so welcome to today's tutorial, and what I'm going to cover in this tutorial is going to be the cutting of the spherical shape using the SolidCAM package. So this is an example shape. It's not exactly the same one you have, but the spherical shape is once again going to have the radius of 25 millimeters. So first we are going to start with the doing of the new milling operation, and we are going to use this one as an external part. In metric, say OK, and now the first thing we're going to do is choosing our machine. I will choose any machine, it's not going to be important now. I hope it's going to work as we wish it to work. So second step is choosing this the stock material. So you choose the part, and the software is going to generate the box around it. Now the most important thing is just remove the expansion of the materials. I don't want to have an expansion for that, because maybe I'm not going to do the cutting. Okay, and 0. Add the box. This will be very important to have the box around the part, and then say OK. Okay, I can't find the box. Stock. The box. Anyway, close. Okay, now the next step is going to be using the coordination system, and because my system doesn't have a lower face to select, so I will define that. Now this point is the 0 point, 20 millimeters, another 25 millimeters. This will make it as 45 in the Z direction, but in the X-axis is going to be 0 for the Y, and 45 for the Z-axis. Enter that. The red point showing at the corner of the box, this red point is my datum point. The next step is we have the X direction has been highlighted. I will choose my X direction with this box. Choose a different axis. Just give me 1 second. Okay, now I'm going to invert that. Yeah, that's the X-axis, and this is the Y-axis, and this will be the Z-axis. So these are my coordinations I'm going to use. So as you can see, that the most important thing is when you are going to have the error, just simply do the changes directly. Now accept that, and this will generate my coordination system at the top of the block. I'm going to start to do work on it. Accept that, accept the position you choose, and then we are going to go for the next operation, which is going to be the machining. Now just remember, you're not allowed to use the eye machining now. You're not allowed to use the eye machining. Instead, we're going to do the step-by-step work until we're going to do the finish of the cutting, because it's required to do the simulation for each step individually. Now for the selection of the tools, we can select tools from the list we have in the library. Now just remember that we have a face milling and we have a spherical shape, so we need to have at least 2 cutting tools. One of them is going to be the end milling, the other one is going to be the ball nose. So I'll go with the end milling cutting tool. I will change the dimension to be 10 millimeters by 10 millimeters our diameter. And now for the shoulder length, because I'm going to do the cutting for 25 and 5 millimeters, and this will make it equal to 30, so the cutting length is going to be 30 millimeters, the CL. Accordingly, the shoulder length should go up to at least 35 millimeters. Okay, now we've done with the tool number 1. Save this one and go to choose the other tool, which is going to be nose ball, and I'm going to leave the dimensions as it is. So we can simply do save and exit, and start with the operation. Now once again, from the list, add milling operation, you're not allowed to use the 2D and the 3D eye machining. You're only allowed to use the 3D machining, 3D milling. Now for the 3D milling, we're going to choose the first operation and define first the working area. So the working area is going to be anything between this ring, that means after the cutting I'm going to have cylindrical shape, and the outside is going to be this edge. Say okay. Now what's happening is that I'm going to cut anything between this circle and this square shape. Press OK. I have to define about the face I would like to go to. So define that, and this will be the face I'm going to work to. I think that the configuration is going to be quite small, so I'm going to leave this stage. I'm not going to define the face now. Instead, I'm going to choose the level to tell the machine what to work to. Now that's okay for this one, and I will go for the tools, and the tool I'm going to use is going to be the flat cutting tool number 1. Say okay. Now it has been selected. The levels, my upper level is going to be 0, the lower level is going to be selected to be that, so it's -25. Say okay. Now the technology I'm going to use is going to be the contour cutting, and be sure that you are going to have acceptable value for the overlap and for the step over. That means the depth of cut for each time. You are going to select the depth of cut depending on your material. It's going to be the aluminium. The wall offset, I'll take this one to 0 and 0. Now I'm going to save and exit this operation. I will do the calculation for this equation to check what will be the movement of my cutting tool. So that's the tool path of my operation. I can simply simulate this one separately. Simulate. I'm going to use the solve verify, so it's going to show the solve. Actually, you have to do that in your assignment. You have to take snapshot for every steps we are making and explain what you're doing here. If I'm going to slow down the speed and press for the simulation, that will be the cleaning process we're going to have for the cutting tool. Now you can see is going to cut a pyramid shape in the middle, which later is going to be transferred into a spherical shape. Okay, now we took everything around to the level of 25 millimeter lower than the 0 point. Now the next step is going to be, I don't want to change my cutting tool at this stage, so I will do the pocket before I'm going to do the spherical shape. So add another milling operation, 3D milling. And now I'm going to define the area of the cutting once again. Now the area of the cutting I'm going to have this time is going to be everything between this edge and that edge. Yes, okay. And this one. So I will remove all the materials between these two areas. Say okay. I can define now what the selected faces are going to work at. So just click that. That's the face I'm going to work at. Say okay. The tool will remain the same tool. So tool number 1. Say okay. the levels 0. No, the upper level is not going to be 0 in this case. The upper level is going to be this one, minus 25, and the lower level is going to be that, minus 30. Okay, and the technology we are going to use once again is going to be the counter, and the maximum level is going to be 5. So take this one to 2 each time. So it's going to cut 2, 2, or let's make it 3 and 2. So 3 and 2, and reduce this value to 0. And save and exit, and done. That's the operation number 2. Calculate this operation. Okay, now this is the toolpath has been generated. It's going to be 2 level, and simply I can simulate this one as well. So solve, verify. We reach at this stage. Play. Now the most important thing, you can see that the yellow area on the cutting tool is always going to be sufficient to go to this depth. That's why I simply just increase the value for the heights of the cutting and the heights of the shoulder. And now we had the cut ready. Now the next step is, now just check something here. Now you can see that the cut has been generated, the fillet on the side. It wasn't a correct sequence, and this is expected because we mentioned that the cutting tool always going to have the fillet cutting. Now the last stage is going to be the cutting of the spherical shape. Now I will show you how simple is that. 3D milling. Define the working area. So now I'm not going to use a working area, I'm going to use a surface. Define the surface, click here, that's it. Yes. And the tool, I'm sorry, I have to make sure. The tool is going to be the nose bowl. So go with tool number 2 this time, say OK. Now for the levels, the upper level is 0, the lower level is going to be selected now, and you're only going to tick that. It's minus 25.0001. Say OK. And the technology we're going to use is going to be, I can use a counter, because actually it's counter cutting. And I can reduce that as much as possible. I'm going to use 1 millimeter, 0.5 millimeters. The wall offset is going to be 0 and 0. This will take longer time, but the outcome is going to be better. Save and exit. Calculate that. Now, these are the complicated toolpath we're going to have, but we're going to have this spherical shape at the end. Now, if I'm going to simulate that, do the solve, verify, play. I don't know why he's doing an extra cutting. Shouldn't do that. Oh yeah, I think because of the face has been. Anyway, I think we should speed up that. Otherwise, we're going to take forever. Okay, now if we get close to that, we go this shape. Now if I would like to reduce these shapes, I can simply choose the setting, different setting, close that, and go to this one and do the editing. Where's the editing? Toolpath, transform, edit. Okay, so the overlap is going to be reduced. So the minimum overlap is going to be 0.1. Okay, and I will take this one to 1 millimeter at this stage. Recalculate. And run. So verify and run. Okay, now we still have a bad surface here. So I think that I did two mistakes. The first one, actually I have to expand the stock at a higher level to generate this spherical shape at the beginning, as well as I'm going to simply change the cutting tool or modify the cutting tool. I will do this one, and the diameter I'm going to have is going to be 4 millimeters. Save and exit. Yes. Okay, calculate that, and well, let's edit that once again. Okay, minimum overlap is going to be equal to 1 and equal step over 2.1. So you can see now it's became too dense, but anyway, this will give me a better results. So if I'm going to simulate that, I'm going to run to the maximum speed. Actually, let's just show you the toolpath. I'm going to repeat the same thing with the solid verify. Do some calculations. You can see that the surface finishing stuff became better than the previous one. Yeah, now I got the almost the perfect spherical shape. Done. Okay, now we have better surface finishing. Sorry, that's too close. Okay, so we got the better surface finishing for this spherical shape we would like to generate. Okay, so I think I explained everything now. So if you have any question, you can still contact me.